So now we'll look at the derivatives of exponential functions, and let's just get a visualization of what the derivative looks like and take a guess on what it could be. So we have this will be e to the x. So we have x values, the y values of e to the x. And let's plot those at 0, it's at 1. At 1, we'll go to 2.7, and 2 is a little beyond 7. 1, 2, 3, 4, 5, 6, 7. At -1, a little below a half, and at -2, getting closer to the x-axis. So if we draw tangent lines and estimate the slope of each tangent line, then we can look at what the graph of the derivative is. So if we draw a tangent line right here, and we just estimate its slope, it looks like it goes over 1, up 1. So we'll say that slope is at 0. The slope is 1, approximately 1. We'll draw a tangent line at this point, and we can estimate that slope is less than 1. Let's say at -1 the slope is about a half. And we'll draw a tangent line right here. And with graph paper we could find a point. This is already at 2.7, so it's a little tough to estimate. But let's estimate that slope, the slope of that line at 1 is about 3. And when we plot these points, we can see what the shape of the derivatives graph is. So 0, 1. At 1 we'll go to approximately 3, 1, 2, 3. And at -1 we'll be at a half. So that looks similar to the original graph of e to the x. And so if I said f prime, it does look exponential, so we see something like that. What would go there? Well, it turns out the derivative of e to the x is e to the x. So that's a surprise. And we can't oversimplify it and just say that every time we have an exponential, it's going to be its own derivative. So there's a little bit more that goes with it. And that is, this is true that if y equals e to the x, then y prime is e to the x. But if y equals 2 to the x, then y prime is 2 to the x ln 2. If y equals 3 to the 2x, then y prime is 3 to the 2x times 2 times ln 3. Now, if we have a rule that works for all of them, so we don't want to just say, well, let's remember this and then remember this. We could just say that we'll always have to have ln of the base. So we copy the exponential function. We have to multiply by ln of the base. But this is just 1, and that's why we don't need to worry about it for this one. But here we'll multiply by ln of the base, and over here we multiply by ln of the base, and this is just the chain rule, so we have to be aware of the chain rule. So we just copy, we do the chain rule, and then ln of the base. Here, f prime, we have an exponential and a polynomial term, so we'll have copy Chain rule is just a 1. We don't have to worry about the chain rule. And then ln of the base. And we wouldn't have to write that. Derivative of x is 1. So then we could just write it as e to the x plus 1. Alright, pause the video and find the derivative of that. So we have an exponential, copy it. Don't have to worry about the chain rule, ln of the base. And then the derivative of that term is 2x. So we have e to the x minus 2x. And then you'll just start not writing that ln of the base when you have an e, because you know it equals 1. And here we have to, I'm just reviewing some notation, find derivative of y. We're going to, we have an exponential, so copy the exponential, do the chain rule, ln of the base. The derivative of 5 is 0, so we could simplify this to 2x e to the x squared. Alright, and pause the video, find the derivative of that. So we use the power rule, that's 6x. And an exponential, copy it. Do the chain rule, ln of the base. So we can have, that's 1, and we just have 3e to the 3x. Alright, so now we have a base of 2. But our rule works, we just follow the same rule. If we have an exponential, copy it. Is there a chain rule? No, we don't have to worry about a chain rule, so then we do ln of 2. Here the derivative of sine is cosine, and we could leave it like that, or put the constant in front. Alright, and find the derivative of this, pause the video. So we have an exponential, copy. Don't have to worry about the chain rule. And then ln of the base. The derivative of tangent is secant squared. And we're just using more of the, all of the same rules, or using the same rule. So here we just have to worry about the chain rule. And we have an exponential, so we copy. Here's the chain rule. And then ln of the base. Another exponential, copy it. No chain rule, ln of the base. So we just put all the constants in front. We could rewrite it like this. Pause the video and try that one. Exponential, so we copy, do the chain rule, ln of the base. Here's an exponential, copy it, chain rule, ln of the base. And that's 1, so we just have 2e to the 2x. And here we can put 3 ln 2 times 2 to the 3x. Alright, let's be careful of the product rule. So if we find dy dx, make sure we have all the parts of the product rule. The first factor, the derivative of the second factor, and that's copy it, ln of the base, second factor times the derivative of the first. We can say it's ln 2x 2 to the x plus 2 to the x. They both have a 2 to the x. And we can factor. Alright, pause the video and try that one. So first factor, the derivative of the second factor times ln of e is 1. I won't write that. And then we'll have the derivative of x squared. Now they both have an x and an e to the x. So x e to the x. Let's take an x out of that. There's an x left over. We took out the e to the x. Take out the e to the x and the x. So there's a 2 left. Alright, let's review the equation of a tangent line. So to find that, we have to find the slope, and then do point slope. So we'll do the derivative of that, and it's an exponential, so we copy, do the chain rule, ln of the base. We need to evaluate it at 1. So here we get 8 times 3, we have 24, natural log of 2, and then we'll have y minus y equals m x minus x. The x value was given. We need the y value for that x value, so you put a 1 there, and so the y value is 8. And we know that the slope is 24 ln 2. On the calculator, we get 16.6, approximately 16.6 for that. We can distribute it, 16.6 distributed there, and then add 8. Find the equation of the tangent line to the function at -1. Pause the video and try that. The derivative of x is 1. The derivative of e to the x is e to the x. Let's evaluate it at -1. And that's approximately 1.368. Y minus y, m, x minus x. When we put the -1 in here, we get approximately -0.632, and the slope is 1.368. And I guess let's just round it to, that'll be 0.6 and 1.4. So we'll distribute 1.4x, distribute, that'll be a 1.4 minus 0.6, and we get 0.8. And we'll stop there.